Hello dear aspirants, this is Dr. Saurabh Sir's classes. Our contact number is 98367 93076. Again, I am repeating our contact number which is 98367 93076. So, this is our contact number and our email ID is saurabhsirclasses@gmail.com. So, if you have any mathematical queries, doubts or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations, like Oxford, APIT, and entrance test, and also. So please feel free to contact if you need any help from us. So now we are going to solve a problem which is appeared in the Oxford AP Calculus previous year questions, and the question is telling us that let us okay, so they gave us a list that our T of minutes and our CT, that means degrees of calculus, and the C is depending on T. Okay, so when our T is 0, C is 100. When our T is 3, that means 3 minutes, then our C is 85 degrees centigrade. When our T is 7, CT is 69. When our T is 12, then our C is 55. Okay. So the temperature of the coffee in a cup at time T is modeled by the decreasing differentiable function C, where C of T is measured in degrees Celsius. For T lying between closed interval 0 to 12, selected values of CT are given in the table is shown. Okay. So now question A is telling us that we have to approximate C dash 5, okay, using the average rate of change of C over the interval 3 less than equals to T less than equals to 7. So the work that leads to your answer and include units of measure. Okay. So let us see what can we do for this. So now I am audible. Okay. So we are going to approximate this thing. That means C mod 5, C dash 5, using the average rate of change over this closed interval 3 to 7. Okay, very good. So we know that our C of 3 is equals to what? That is equals to 85. We are getting this from this table. And our C of 7 is equals to a 69. Very good. So now the approximation of C dash 5 will happen by the average rate of change of C mod T over this interval, closed interval 3 to 7. So our C mod 5 will be approximated by this C mod 7 minus C mod 3 by 7 minus 3. So that will be 69 minus 85 by 4, and that is equals to minus 16 by 4, and so that will be minus 4 degree centigrade per. So the final answer of the first question will be minus 4 degree centigrade per minute. Okay, so let us see what the second question telling us. Use a left Riemann sum with the three subintervals indicated by the data in the table to approximate the value of integral 0 to 12 ct dt. So interpret the meaning of 1 by 12 integral 0 to 12 ct dt in the context of the problem. Okay. So let us see what can we do. So we are going to approximate this thing, integral 0 to 12 ct dt. Very good. Using a left Riemann sum. So now the subintervals are closed 0 to 3, that is closed 3 to 7, and that is closed 7 to 12. Very good. So now the left endpoints are C of 0 is equals to 100, C of 3 is equals to 85, and C of 7 is equals to 69. Okay. So the left remain sum, by using the left remain sum, we are going to approximate this thing. That will be, or that can be approximated by C of 0 into 3 minus 0 plus that will be C of 3 into 7 minus 3 plus that will be C of 7 into 12 minus 7. So what we will finally get, our C of 0 is 100. We know that 100 into 3 plus we will get 85 into 4 plus that will be 69 into 5. So finally we are getting 300 plus that is 170 into 2. So that will be what? 340, and this is 5 into 69. So that will be 45 and we will get 30 here. So that will be 350. Okay. So that will be what? That will be 600 plus 85. So 680. So the interpretation of 1 by 12 of this thing, that means the interpretation of 1 by 12 integral 0 to 12 Ct dt. This represents the average temperature of the coffee over the first 12 minutes. So the final answer of it will be, sorry, I have done some mistake here, that will be 9. So that will be 985 upon 12 degree centigrade. Okay, very good. So now we are moving to the question. Now we are moving to the third part of this question. So this thing is telling us that for T belonging to the closed interval 12 to 20, the rate of change of the temperature of the coffee is modeled by C mod T, C dash of T is equals to minus 24.55 e to the power 0.01 T by T, where our C dash T is measured in in degrees Celsius per minute. Find the temperature of the coffee at time t equals to 20 and show the setup for your calculations. Okay. So let us see what can we do. So now we are going to find the temperature at our t equals to 20. Okay. So given our C dash t is equals to minus 24.55 e to the power 0.01 whole by t. Very good. Now, so for 12 less than equals to t less than equals to 20, given thing is what? Given C of 12 is equals to 55, which we are getting from the table, and our C dash t is equals to this, which is given here. That means that is minus 24.55 into e to the power 0.01 t upon t. Okay. So we have to integrate C dash t from t equals to 12 to t equals to 20. So what we would get? So C20 equals to C of 12 plus that would be 12 to 20 C dash t dt, that is equals to C of 12 is equals to 55. We know that. So that will be integral 12 to 20 minus 24.55 e to the power 0.01 t up on t. Very good. So in the next step, we can do that, or if we apply the numerical approximation, then we will get this thing will be, or rather we would write this. Okay. So now using numerical integration, example Simpson's rule or a calculator. So what we will get? So uh, can we calculate this thing? Yeah. So by using the Simpson's rule, we will get the answer as that will be multiplied with 0.10. So that would be approximated to minus 2.6, approximated. Okay, so our C of 20 is equals to, or let us call it approximate to 55 minus 2.65. We would write this. So we would get 52.35 degrees centigrade. So the final answer is this. So now we are moving towards the question number D. For the model defined in part C, it can be shown that C double dash T equals to 0.02455 e to the power 0.01 T into 100 minus T by T square. For 12 less than T less than 20, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. Give a reason for your answer. So let us see what can we do for this. Okay. So determine if the temperature is changing at an increasing or decreasing rate. Okay. So given C double dash T is equals to 0.2455 e to the power 0.01 T into 100 minus T whole by T square. The whole thing by T square. Very good. So now we are going to analyze this thing. Analyze this thing which is happening here. So for 12 less than equals to T less than equals to 20, T less than 100, so 100 minus T is positive. Very good. Since our e to the power 0.01 T is positive and our T square is also positive, and so we can say that our C double dash T is also positive on what? On this interval, or rather we would say closed interval 12 to 10, 12 to 20. So the conclusion will be what? Our C double dash T is greater than 0 implies that C dash T is increasing. Since C dash T is negative, the uh, temperature is decreasing, and so an increasing C dash T means that the rate of cooling is slowing down. So the temperature is changing at a decreasing rate, because let me write it in the screen so that will be easier to see. So the temperature is changing at a decreasing rate because C double dash T is greater than 0, meaning C dash T is increasing less. Okay. So this thing is happening, or this thing is the answer of our question number D. So fine, so good. So let us sum up the answers of this question. So so the answer of the first question, that means the approximation of C dash 5 is equals to -4 degree centigrade upon minute. Okay. And our 1 by 12, 0 to 12 CTDT is 985 upon 12 degree centigrade. And for this 12 to less than equals to 20 and this thing, in this part we would get the answer, which is 52.35 degree centigrade. And in the last we called it decreasing rate. Okay. So these are the answers of this question. Hope you understood, guys. Again, I am telling that if you are having any doubts or any queries or anything, so please feel free to contact on this number. So then, yeah, or you can drop an email to our email ID. Then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations like Oxford AP, Calculus, Statistics, etc. So please feel free to contact if you need any help from us. Okay. Thank you, guys. Hope you understood. Thank you.